Imagine this. You are in a lab in Germany, and in front of you is a machine the size of a small house, glowing like a miniature star. But it's not science fiction, it's not a prop for a movie. It's real, and inside it, a wonder is happening. The same kind of wonder that powers the sun. For 43 seconds, this machine held a sun-like fire, no smoke, no pollution, no fuel trucks, just pure energy, born from light itself. This is wonders of science, and today we dive into one of the most hopeful stories in science, the incredible leap forward in creating star power on Earth, and how it might change everything we know about energy. Let's go back for a moment. The sun, our giant neighbor in the sky, does not burn like wood or coal. It fuses. It crushes the hydrogen atoms together with such immense force they become something entirely new. In that process, it releases enormous energy, and that's what makes sunlight. It's a process of immense power, and for over 70 years, scientists have dreamt of harnessing the same power here on Earth. Now imagine just for a second if we could do that. No pollution, no carbon emissions, fuel made from water and a rare form of hydrogen. And energy so powerful, one glass of it could power an entire city block. That's the dream scientists have been chasing, and recently that dream came closer than ever before. In July 2025, which is about right now, a team in Germany held that reaction safely for 43 full seconds. It might not sound long, but it's a huge deal. Why? Because it means we are learning how to hold a tiny sun in our hands without letting it go or explode. Here's the challenge. You can't build a container out of metal to hold any kind of heat the sun makes. Metals would melt instantly. So, what do scientists do? They don't hold the fire, they hold the space around it. They create invisible fields like magnetic bubbles that keep the super hot gas suspended in mid-air, away from the walls. It's like levitating lightning inside a hollow shell of magnets. But it's not easy. The fire wants to escape. It wriggles, dances, and lashes out. And that's why holding it even for 1 second has been incredibly hard for decades. But in Germany this year, with a machine that took over 1 million hours of planning, they finally held that reaction stable, clean, and hot for 43 seconds straight. It may sound small, but it's a monumental breakthrough. The difference between a fleeting spark and a sustained flame. Let's think big. Right now, most of our electricity comes from burning stuff like coal, gas, oil, and while it's kept our lights on for a century, it also heats the planet and pollutes the air. Nuclear fission power exists too. It splits the atoms and creates radioactive waste. But fusion, What we are talking about today is fundamentally different. Fusion uses a tiny bit of fuel that comes from water. It's inherently safe. If something goes wrong, it does not explode. It just stops. And the best part, it does not release any carbon in the atmosphere. But how do you even begin to unlock such power source? Well, you need specific types of hydrogen, special isotopes called deuterium and tritium, which are easier to fuse than regular hydrogen. The good news, deuterium is found in ordinary water, and there's enough of it in the ocean to power humanity for thousands of years. To overcome the natural repulsion between atomic nuclei, you need to heat this hydrogen to over 100 million degrees Celsius, hotter than the center of sun itself. At this extreme temperature, hydrogen turns into a soup of energetic particles called plasma. It's often called the fourth state of matter. It glows, it's alive, and as you can imagine, it's nearly impossible to contain directly in any solid material. You can't put this plasma in a metal box. That would melt instantly. So, how do you hold it? As we discussed, it's with incredibly powerful magnetic fields shaped into invisible cages that suspends the plasma in mid-air, away from the reactor walls. Two main designs are currently leading the way. The first one is called a tokamak. They are simpler donut-shaped chambers. The second one is called a stellarator. These are more twisted, more complex, but often considered more stable for longer operations. Think of this as magnetic bottles designed for tiny stars. The energy from fusion could truly power the world for everyone. No compromises, no smoke, no climate damage, just clean, endless light. The 43-second success we saw in Germany isn't just a fleeting moment, it's a profound validation that this dream of clean and endless light is truly within our grasp. Now, 43 seconds is great, but we need more. Imagine if your fridge worked for 43 seconds and then shut off. Or if your car ran for a minute, then cooled down. To be useful, fusion energy must last for hours, then days, and then eventually years without stopping. Scientists are now working on making the system even more efficient, turning the fusion energy into usable electricity for our grids, building full-size plants that can actually power cities. And of course, making sure the whole thing is safe, reliable, and affordable for everyone. Now, I know it won't happen overnight, but many believe we will see the first fusion power station within our lifetime, maybe even in the next 20-30 years. Here's what's truly amazing. Fusion energy could bring light to places that don't have enough light. It could power homes, schools, hospitals without burning anything. It could make electricity cheap, clean, and everywhere available. Imagine a world where we don't fight over oil, a world where our children breathe cleaner air, a planet that runs on the same fire that fuels the stars. It sounds poetic, but it's science, and we are on the edge of it. In chasing the stars, we may just light the earth, And in building our own sun, we might finally outshine the darkness. And that was the story how we brought the heart of a star to Earth. If only for 43 seconds, it may be a small moment, but sometimes it just takes a spark to change the future. If this episode made you pause, wonder, or smile with curiosity, I invite you to follow or subscribe to Wonders of Science. New episodes drop regularly, and each one explores a mystery, a breakthrough, or a fascinating truth that's shaping our world. If you have got thoughts, I would like to hear from you. Please drop a comment, send a message, or share this episode with your fellow curious souls. Until next time, stay curious, stay inspired, and remember, science isn't just about answers, it's about asking better questions. This is your host Arindam Banerjee signing off.